Good morning. Good morning, everybody. Welcome to the 34 members meeting of the Club of Bologna, and welcome to the Agri-Levante Fair in this wonderful city of South Italy, that is Bari. The opening session, just a few words before leaving the floor to Maria Teresa Maschio, that is present, the president of Ferro Coma, for her welcome address. The 34 COB meeting will be followed by 42 COB members, and this corresponds to a participant rate rather similar to the one that we have had in the last edition in Agritecnica. A special welcome to the new member. Welcome to Fabrizio Mazzetto, and welcome also to the Pellizzi Prize winner that of 5 years ago, that are the new members of the Club of Bologna. Welcome to these young new members. Our agenda in few words. We start now with the first session after the welcome address by Maria Teresa Maschio, the president of Ferro Coma. The first session is the session that is chaired by Giuseppe Gavioli, and rapporteur is not Marco Grella because has problem, but Andriy Yaskul, that I thank especially. We have a lunch more or less at 12:30. And in the afternoon, there is another specialized mechanization session that is chaired by my friend, Professor Alessandro Leone, full professor at the University of Bari. Please, Alessandro, show you to our... Okay, Alessandro. Thank you, Alessandro. In the afternoon, we, starting from here, reach the center of Bari for a guided tour, and then we have dinner in an amazing restaurant in the center of Bari. Tomorrow, Sunday, we have the transfer from our hotel to here very early at 8:30. Remember, 8:30 we have to leave, because the program is very rich, and we have to finish all at 12, yes, at noon, because most of us have to take their flight to return home. So thank you very much. I declare open this edition of the Club di Bologna. My first edition, like a president, I'm a little bit emotional, so please, sorry me. And I'm very happy to leave the floor to Maria Teresa Maschio. Thank you, Maria Teresa.
I'm always emotional. I tell you why, because to see all the maximum experts in agriculture and science, it's for me something very, it's an honor. It's an honor. So awesome. So it's a great pleasure to bring the greetings and the welcome of Federal Coma to this 2025 meeting of Club of Bologna. It's also a pleasure to once again meet your president, Danilo Monarca, and all the experts who make up the club. As is well known, the Agri-Levante exhibition was established with aim of contributing to development of the agricultural economy of the area Mediterranean, and it's distinguished by its focus and offering specific solutions for the crops and the farming models found in Southern Europe, the Balkans, the Middle East, the North Africa, and Sub-Saharan countries. In this moment of our history, marked by conflicts, geopolitical tensions, and trade wars, the agricultural machinery industry is looking with a lot of interest to the Mediterranean area, which appears more stable and shows better development indicators compared to the other regions of the world. However, we know that the simple matching supply with the demand is not enough to succeed in the markets. It's essential to correctly and effectively understand of the specific needs of the various agricultural systems in the region and to develop technologies suited to each country, along with a system of services, consulting, technical assistance for the local operators. From this perspective, the work of the club becomes especially important, as it has always analyzed the evolving scenarios of agriculture and agricultural machinery, providing different types of machines, skills, support needed to help the growth of different economies. Every contribution and every recommendation that the club may offer with regard to the Mediterranean area will be extremely valuable to us. Once again, welcome to Agrelevante, to the exhibition, and thanks. Thanks very much for your work and for your important work for us. Thanks. Good work, good work, good work.
Thank you, Maria Teresa, for your wonderful words. And now I leave the floor to Giuseppe Gavioli, the member of the managing committee, to drive the first session. You can also do from the chair. Thank you.
Okay. Thank you. Again, good morning, everyone, from my part. Talking about the future is always a big challenge. And so I started thinking about how to talk about evolution and look into the future, thinking about which are the drivers that push toward the future. And I identified the three main drivers. The first one is farmers' needs, obvious. We need to look to the farmers' needs, and in particular to the ones that we often forget, that are the ones in countries like, in continents like Asia, Africa, or Latin America. So there will be a big, beautiful contribution from FAO to discuss about farmers' needs. Then another important driver, in my opinion, is creativity and innovation. So I invited David Wilkie, responsible for industrial design in CNH, to talk about ways of dreaming the future, dreaming what is not here, what we would like to see and we don't see yet. So pure creativity, pure looking to the future before the future matures in order to push toward the future. I believe it will be an original contribution, and I believe it is a driver. Then the very last one is technology. Last but not least, because technology is a big driver. And to answer the question of how the future tractor will be and other similar questions, we will gather 4 manufacturers representatives around a panel discussion coordinated by Professor Carl Renius, who will ask interesting questions to these people, and we'll see what they think about. So we'll try to identify possible trends and drivers for the evolution of tractors of the future. Thank you. So the first speaker is Karim Houmi, representative of FAO in Africa. Please come, the floor is yours.
Thank you. Can we use my presentation here? I don't know how it's... Yeah.
E touch? No.
Sì, a touch. This? No. This?
Yeah, this one.
This one.
5.
Non prendo.
Okay.
Okay, you can follow. Yeah.
Okay. Okay. Okay, thank you.
Yes.
Okay. So it's a great pleasure for me to be here today and to speak about this very important topic titled Evolving Farmers' Needs and as Drivers of Next Generation Tractors Designed in Africa, Asia, and Latin America. And all we know that tractors are playing a very important role in improving, increasing productivity, improving work efficiency, and also in globally, let's say, also improving rural development. I think, and I would like to use this opportunity to congratulate the organizer to choose this, to select this very important topic. However, as the chairman said, we have to know exactly the farmer's need. Any innovation for tractors should start from the farmer's need. So this presentation was prepared by Joseph Kinsley as team leader at FAO headquarters, and myself. And the outline for this presentation. So I will start with the introduction just to set the scene, and will present what is the current situation of tractors in these different regions. I mean Africa, Asia, and Latin America. And then I will present, as we already talked about, key drivers for changing the needs. And then what are the design principles for the next generation tractors? What are the barriers? It's very important for scaling this next generation tractor design. And I will propose also some scenario for the future for developing these tractors, and then some recommendations and the conclusion. This is very, in short, what we're talking about in this presentation. So let's say for the first part, about talking about current situation, I would like to define maybe the baseline of the situation of tractors by talking about what is the situation, and let's also talk about some, let's say in brief, what is the tractor technology landscape. I mean talking about the tractors now. And then we will discuss, based on these drivers that we will define and according to the farmer's needs, we will talk about what should be the tractor in the future. So I think what's very important to design tractors in general that make a real difference, we must start by understanding really what are the farmers' reality. I mean, to understand their working conditions, to understand also their challenges, and also to understand their aspirations. And by designing solutions around farmers, we ensure the technology is not just advanced, but also practical, affordable, and impactful. And that's really very important. And this is really what we have to understand. And we can say also that developing tractors should be demand-driven and not technology-driven. And that's also very important. And this is what we are discussing during this presentation. So let's provide you with an overview about what is the situation about mechanism in different regions. I am so sorry because the data I will present are very, let's say, old, are not updated, because this data that we have And at AFAO, we stopped publishing data in 2009. But this chart you have is very interesting to share because it shows the evolution of tractors, number of tractors per 1,000 workers. And if you see the comparison between the different regions, we note that, for example, at the independence in 1960s, for example, the level of tractors in sub-Saharan Africa was the same as in other regions, in Asia and in other regions. But after, let's say, 5 decades, we saw the difference. For example, in Latin America, the number of tractors increased importantly. And then we can have the Middle East and Asia and East Asia. But Africa, as you see, is still stagnating, and the evolution is not visible. And this is what is the situation. So this is the situation about the tractors in these different regions. The second chart is about a global industry. And this is what published by SEMA in 2022. And we see again here the percentage of the market of machinery in general is about 3% if we compare it with the other regions. So the conclusion of that, unfortunately, Africa is still underdeveloped in terms of mechanization. Now let's present an overview of what are the tractors now in these regions. Simply, we can say we have the tractor as a very simple tractor. For example, for the engine, generally it's diesel engine, and the power, it's, let's say, less than 80 horsepower. Because I'm talking about general, I'm not talking for large scale farmers, but large scale farmers you can find also very tractor with higher power. So the second characteristic or feature for this kind of tractors now, we have emission regulation. We have some regions started to work on this, but for example, if in Africa, for example, there is no regulation about this. About transmission and hydraulics, so in these regions, we are still using very, classical transmissions as manual gearbox, for example, and also, for example, for hydraulic as a classical. This is what is using for the moment. For example, for the comfort and safety, now let's say in several countries we start to see some safety advice that we use as for example, as ropes and safety belts. So this is, and cabin, for example, some comfort also. But again, this is only in the large-scale farmers. But for others, we still have tractors without this kind of systems. The other one about connectivity, again, in these regions, we can say that it's rare that to find the tractors with digital systems and so on. Because as we will see later, one of the driver also is the infrastructure. About connectivity is not, spread everywhere. So we have this a problem to develop this kind of technology in these regions. And maintenance and affordability, we have local repair, common, and spare parts are scarce. So we know this problem in these regions. So we haven't enough spare parts, and we have a problem of repair and so on. And for the cost, also the cost is a barrier for farmers, individual farmers. For this reason why we see the development of higher service provision. This is very important. So by presenting this, just to give, as I said, what is the situation now. Again, we have the development of mechanization. We have variability of development mechanization. As I said, Africa is lagging behind. And about this technology landscape, in general, we have still using very simple tractors, as you said, with simple technology and so on. So now let's move to our topic. I mean, what are the drivers for this farmer's need? And that is really very important. So we have many drivers. Starting with first drivers are linked to small and fragmented land holdings. And that is very important. You know, in this, mainly in Asia, let's say in Africa, what is dominating is very small scale farmers. And for this reason, many smallholders farmers consist of multiple very tiny plots. And really, this is very important to mention. We have also fragmentation, increase transit time for operations, or let's say in general, they are increasing what you call it downtime, and for sure that reducing the performance of tractors in general. So this, according to this situation, and let's say this constraint, this situation that we have, let's say the farmers' needs, what they need compact tractors. It's really very important, and maneuverable also. They can move easy from one plot to the other plot, for example, and the machine suitable for narrow and irregular plots. And that is what is the need for this kind of regions, and for due to the smaller fragmented land holdings. And the last one, first, fast switching, minimal downtime between plots. Again, is related to the performance of the different tractors. Because as we have, as I said, very small land holdings, we need tractors that are compact and also they have high performance. That's really very important. So this is kind, let's say, the first drivers that link to small fragmented land holdings. So the second one, and I do believe that is one of the very important drivers that are linked to the labor shortage and raising labor cost. And you know that in many these regions, and mainly in Africa, let's say the labor cost is rising because we have, let's say, migration. That's very important from rural to urban areas. That's very important. And maybe you have also other factors that also playing a role why this labor cost is rising. And the labor loss is rising. This is one very important drivers. And what is the application for the farmer's need? So machines offering higher throughputs, high performance. And that is a very important. And also one of very important, easy of operations, less, let's say, less labor in general. That is very important. And reduce downtime and fast tasks show switching to minimize productivity time. Let's say we have less laborers in the field, and we need tractors that will be more performant. I mean, working very big areas in short time. Let's see it in other way. And that is also very important labor. And for me, this kind of drivers, what we say is very important for shaping the design of tractors, but also for developing mechanization in general. And we see in many regions, the labor is really an issue. For them, this is very costly, and sometimes also have the effect on the crop production. You know, with the climate change, and I'll present this later, we have the cropping calendar is changing, and sometimes the farmers have to intervene immediately and quickly to preserve their yields, and this is very important. This is kind of things. I know, for example, some examples. The last I was in Mauritania, for example, is not about tractors, it's about combined harvesters for rice production, for example. And they have to, in the south of Mauritania, with irrigation area, and almost all the system is mechanized. We have combined harvest everywhere, and the reason why, because the farmers, they have no choice. They have to harvest as soon as possible. If not, they lost their harvest. And this is very important to mention. So this, because manually is not possible. And it's not possible for the time, but for the cost also. So this is one also with drivers. So we have to review tractors, the design, to be fast, but also to develop mechanization, to have more tractors and so on. So this is application of this driver. The other one, or the other drivers that are linked to crop diversification. And this is mainly for Asia and Latin America. There are some initiatives to develop new practices to mix several crops in one plot, and for different reasons. One of the reasons, for example, to reduce, let's say, economic risk. I mean, if we sure one crop it doesn't yield, so it can be compensated with another one. But there is other reasons. Some of them are related to the soil health, for example, and the others are limited to the let's say, for disease. We can interrupt the disease cycle, so we can protect more these crops and others. And this, how to say, add a complexity for tractors, because we need tractors that can be adaptable for the situation. What is situation with different, let's say, spacing for crops, because it's different. The width, for example, sometimes the ground clearance, it will be adapted, and the width of tractors. So many, aspects about the design of tractors have to be adaptable to this situation for this diversification. The other drivers linked to the climate and environmental pressure, as you see, we have, as you know, we have many problems of the climate change, with droughts, with flood, with erratic rains, and I said also with this changing in crop calendar for different crops. And we have also soil degradation is a problem. We have erosion. These all are drivers to think or rethink about the design of the tractor. And we have also some drivers linked to the emission and fuel concern. So according to these drivers, some needs emerged from the farmers to have a resilience and adaptive machinery. And that is very, very important. I mean, to have some machines are robust to resist to very difficult conditions as floods, for example. And we need also low disturbance tools. So here I am talking about conservation agriculture, to have tractors that with more power to use these seeders, because as you know, for conservation agriculture, generally we use a little bit heavy seeder to allow the machine to penetrate in the soil. And for this reason, we have kind of tractors that will be with more power. This is one thing. And we have also, when we say fuel, of course, we are talking about also to develop electrical tractors. This is also one of the needs of farmers in the coming years. And we have already some experiences. For example, as you see, in Rwanda, there is one very interesting example, a pilot project developed by Volkswagen, you know, this Germany company car. And this tractor is electrical tractors. This is one very interesting. But we have also experiences in other regions. I know in China also, they are developing also electrical tractors and so on. And that is very important. This is also maybe the future. As you know, we are now, let's say, developing the electrical cars, but in the coming years, it's turn for tractors also to develop electrical tractors. So the other one is what I would like to talk in this presentation, not only technical, because also we have some problem about finance. And here it's about limited capital and access to credit. And that is very important. As you know, this machinery in general is a little bit expensive. So it's high upfront for tractors. If we compare it with the capacity for farmers to invest in mechanization, so we have many problems at this level. So for this reason why, and we have other reasons also. We are talking about reluctance by lenders to assume risk. That is very important. It's a question of risk. And about farmers' needs, lower capital entry, shared models, and for this reason why, for example, what we are trying to promote is to innovate in developing different business models for higher service providers. As you know, we are a cooperative, we have enterprises, but we have also other models that are really very important. And we have also credit, also working on credit, on innovation for credit, guarantee, for example, but also we are developing some leasing. This is many regions are developing this kind of credit, which is very, very interesting to promote. The other driver, those are linked to infrastructure, and that is also one of the very important, let's say, constraints for mechanization. Instead of moving tractors, but also for spare parts. And I think that is very important. We have, you know, in these regions in general, but let's say mainly in Africa, we have very poor rural roads, for example, which are unpaved. And generally in wet season, it's very difficult to use these roads. That is a problem. And we have long, I said, travel distance, limited repair shops, and skilled mechanics. This is one of the problems in these regions. Gap in energy, fuel, and charging infrastructure. And one also of the constraint that we have is about connectivity. That means if farmers would like to develop some digital, let's say, systems for tractors, it's really very a real constraint for this in these situations. So farmers, they need, let's say, in this case about tractors design, they need some tractors should be robust, and why not portable? We can, we can say use a truck, for example, to transport, as we know that already for combine harvester. In many regions, we transport. And you can imagine also, in case we have these compact tractors, it can be transported by truck or other systems. This is also a system. And the last, let's say, drivers are linked to women's involvement and inclusiveness. As you know, in many regions, women are playing a very important role are, let's say, very important part of labors. And unfortunately, the technology, when it's built, is male assumption. We consider that this tractor is used by men, and that is a problem. So, and the other problem also for women, they have very limited access to resources, as credit, as land, and so on. This is what the situation in many regions. And we have fewer opportunities for mechanization services. It's rare that you find women involved in mechanization services. And that is one of the drivers. So for this reason why we need to design tractors, ergonomic design for diverse bodies, I mean men and women, for example, with taking in consideration the steps, high and other systems, and very easy to handle for women as for men. This is what should be the design of tractors in the future. I mean, by considering that the tractors can be used by men, but also used by women, and that is very important. So after developing all these drivers and farmers' needs, now what is the design principle for the next generation tractors? So to meet the need of farmers, the tractors should be compact. I said, for example, according to what I already said, farmers are using very small plots, so very compact tractors is very important, and tractors with adjustable chassis, for example, and narrow width, as I said, for the case of if you would like to diversify crops, to mix crops also, that's very important. Other principle also is modularities. I am sorry, I don't see well because the screen is very small in the computer, and I have some troubles to see. So modularity, tractor with quick changes, mounts, and modular attachment. As we said, what we are working in very small plots. In many reasons, we have to change different implements. So tractors should be also with system that we can change, implement very quickly. We have with high performance, tractor with assisted automation and ergonomic control. That is very important. As we already said that, for example, for this labor problems, that is really an issue. Resilience also is one principle. We have to develop tractors are more robust. They can resist to different situations, at flood and other situations. We have also conservation. As we said, now we are promoting this conservation agriculture in the coming years. So we have tractors that can adapted for these seeders used for conservation agriculture. And we have clean propulsion, that is about electrical tractors. I think that is the future in the coming years. And survivability, I mean, tractors can be repairable easy, also report, remotely. And that's, if, for example, we can imagine we have some systems with the operator in the field, for example, and he can, repair his tractor just with communicating with the mechanics in the city, for example. This is kind of things that we can develop in the coming years. But tractors also should be very easy to repair. This is kind of things. So let's now talk about some barriers for scaling this next generation tractor design. So unfortunately, in many regions, the tractor is not really profitable. Why? Because it's limited. For example, I know that for many regions, it's limited to land preparation. And according to this, the tractor generally is used only one period per year. Let's say 100 hours a year. And if you use it for this 40 hours a year, for sure it's not profitable. And that is one of the barriers for these regions, mainly in Africa. And we have also another barriers about policy and institutional gaps. There are many efforts to do about developing strategies are suitable for developing tractors or let's say mechanization in general. Ecosystem fragility, this is also a barrier. I mean, that's not talking about repair system, workshops, spare parts, and so on. And we have also behavioral and information barriers. That means tractors that are not aware about the role of mechanization. And sometimes they are still using manual because they consider this is technology is external, so we are not using. This is also one of, or they don't know exactly what is the role or what is the benefit of tractors and mechanization in general. Now let's present what are the scenario paths in the coming years. So, and this is very interesting and can be also one of the discussion in this group. So I am proposing 3 scenarios. The first one is baseline, that means we have modest growth with constraint persisting. If we don't tackle this constraint, we stay as we are. Let's say the pessimistic scenario. The second one is optimistic one, is accelerated adoption if enabler align. And this, that consider that we can multiply the mechanization or number of tractors 2 by 2 or 3 if they have some enablers. That is very important. And the last one, and that is very interesting, what we call it leapfrog. That means these regions, they can jump. That means they are not obliged to follow the same path as the Western world. Just jumping from the situation now to very sophisticated mechanization and robots and other things. And this is one, I think it's possible. I do believe on that because, as I said, in these regions, according to the problem of labors, is costly, and then this is possibility. And we have some examples. Just to give one example, even it's not linked to mechanization. For example, the mobile phone. We have mobile phone everywhere, even in this country. About mechanization, we have also some experience. You have developing some digital platforms in India, but also in Africa, to connect farmers with tractor owners. So this is very sophisticated. That means we can also develop other technology. And I see here with us Professor Salah from University of Disney. He's also developing some robots that can adaptable for very small farmers, even in developing country. And this it's possible. I mean, it is possible. As I said, I believe to this scenario with leapfrogging. What is frogging? To jump, to go directly to very more sophisticated, even for these regions. And some enablers for sure for that. We need policy institution reform, finance credit, that is very important. We have service ecosystems, I mean part network about spare parts and other things. Digital technology is very essential, and partnership and scaling models. All these are very important enablers to push for this scenario I just presented. So some recommendations. So for different stakeholders, for designers and engineers, to co-design, again, as we said, based on farmers' needs. And that is very important. The other recommendation, and this is for government and policymakers, reform import tariffs, standards, subsidies, and support mechanism strategies. And that is very important. What the FAO is pushing for that, to support countries to develop these strategies and policies. That's very important. For funders, investors, and donors, provide the risk mechanism, pilot financing support, local supply chains. For service providers, entrepreneurs, to scale mechanization as a service models, as already said, build spare parts and repair networks. And the last recommendation for extension and training, this is very important, to improve skills for farmers and users in general. So for conclusion, the last presentation, so I think the core message, tractors must respond to farmers' evolving needs. This is what I have said from the beginning. And we have some drivers that we have to take into consideration, and it implies we have emergence, some needs, farmers' needs. That's very important. For the key takeaways, needs like compactness, modularities, resilience, serviceability, affordability, guide design. This is very principles, let's say, guide design. The second one, even excellent design must overcome financial, infrastructural, capacity, and institutional barriers. And the last key takeaway, with aligned policy, finance, and ecosystem, transformational growth is possible. And that's, I finish my presentation, and thank you for your attention.
Thank you, Karim. Very interesting presentation. A little bit longer than expected, but I think it was worth to listen. Let's quickly move we will concentrate the questions at the end of the session. So let's quickly move to David Wilkie with his presentation on dreaming the future.
A service communication, there is the internet Wi-Fi. The Wi-Fi is B2B agree, and the password is B2B RE25. Okay, if you need. Thank you.
We ready?
Yes, we're ready. Thank you.
Can you hear me? Is this good? Hi everyone. Hi everyone. I'm David Wilkie. I'm Scottish, but based in Turin, Italy. I'm head of industrial design for CNH, and I'd like to just give you a little bit of insight into my world and the world of my industrial design team, and a little bit of CNH. So it's a bit of dreaming, and I'm going to start with a very old video that we've never shown, because it wasn't appropriate at the time it was done. But it's becoming more appropriate now. So, let's see. considering the evening. There, yeah. Okay, a little bit of fun. And it's just to say that, you know, robotics and autonomous is something that people are worried about or they're ready for. And at that time, they were definitely not ready for it. But it shows that it can be useful and is definitely becoming more appropriate. Oh, let me just, there you go. So yeah, I'm just going to skip quite quickly a little bit of my background. I'm kind of a fish out of water here because I come from an art background. This is, you can read all this, but it's not so interesting. I started my life in Scotland, in Glasgow, at the Glasgow Art School, where I did fine art and then product design. And I just wasn't quite sure what I wanted to do, but I found out during my course that there is such a thing called industrial design, product design, and even automotive design, which I did not know existed. I was really obsessed by cars and obsessed by design. My brother is a carpet designer, so textile designer. So we always had design in my family. I found a guy at Glasgow School of Art who told me, if you want to be a car designer, there are only two places in the world that you can go to. This is many years ago. One is the Art Centre of California, and the other one was the Royal College of Art of London. So I tried my best. I didn't get in. I had to go back home. I had to study. I struggled to draw. I was very good in 3 dimensions. I was an ace at cardboard modeling, but I couldn't really draw well enough. So I tried my best. I studied more, and I came back and I got in the second time, sponsored by Ford of the UK. And you can see the little motorcycle up there. I made a little model because all the guys around me were amazing at drawing. They were like stars. And I looked and thought, what am I going to do? So I built a model. Anyway, during that time, because when I was at Glasgow, there's a dumper truck there, hydrostatic dumper truck, because car design was seen as to be frivolous and not a realistic thing to do at Glasgow. You had to do something real. So I found that by making a dumper truck, it was seen to be more real, and it had wheels. So I was getting closer to cars, but still in the world of, construction equipment, which is funny because I find myself today in the same world. I learned to draw at a place called Ogle, and I'll show you this. I did a stage in this company called Ogle Design, north of London, and the owner of the company took me down to the workshop, and they were building the speeder for Star Wars, but the movie hadn't come out. So I just walked by it, and the guy, and he said, "Oh, this is just some prop for a movie we're making, and now it's quite iconic." I also designed the Smith's clock update, which in the UK was quite, used everywhere. So I did a lot of different things. And then Seymour Powell, he's the guy who taught me to draw properly. Seymour Powell, they're consultants. They're quite famous in the UK because they invented the cordless kettle. And the cordless kettle you get everywhere, certainly in Britain, but around the world. And they did the inside of the space shuttle, the Virgin. I spent 31 years in car design through Peugeot Citroën, through Ford Advanced Design in Turin, I was head of Bertoni, director of Bertoni in Turin for 5 years. I did electric mobility with a friend of mine, Murat Gunak, in Switzerland and then in France, a little too early. So I spent 31 years, lots of fun, but car design's a bit repetitive. So after a while you wonder why you're doing it. You do another one, you do another one. I did a lot of Chinese cars. I worked a lot in India. I did some truck work with Tata Motors and Mahindra. But then you think, yeah, I've done that. So what can I do now? So I got a call to come over to CNH to join this amazing world of agriculture, construction, and at that time trucks as well. So it was a huge change to me. I had to learn a lot. But it really was amazing. See if I can move on. There you go. So I moved from doing the car stuff to trying to bring what I knew into the world of agriculture, construction, equipment, and also trucks at that time. I knew very little about the world of agriculture, so luckily I have a very, very talented design team and engineers who really helped me along. So I think that what I achieved over the years is not so much myself, but thanks to them. But what I hopefully gave and give is a little bit of this dreaming of what the future can be. Because it was very interesting previously hearing that we have to design for the farmer's needs. And that's exactly what we do today. And as a designer, we have to listen to what's needed, but nevertheless, you have to dream of what could be. And sometimes the farmer doesn't really know that because they know what they have. And if they know what they have, they don't quite know that they could have something different or more, you know. So that's part of our job in design as well, dreaming a little bit more. I just go through some of these. These are future concepts. So this, if I go back, this is a wheel loader concept from some years ago, built in Lecce, in Puglia, and presented at the construction show Bauma some years ago. And the whole idea was to make life on board safe, easy to work with, but also enjoyable. You know, when you work all day with these machines, you have to be proud of them, you have to love them, and you have to enjoy them. Especially when it comes to agriculture, I believe. This was a concept that cost me a lot. It cost me a lot in credibility because I was determined that we should do a ground-up tractor concept. My design team loved the idea, but within CNH, the engineering team, and I just want to be open about it, I don't think they got it because it wasn't real. It was thinking of what could be. It was electric hybrid, wheel motors on each wheel, a specific chassis, a lot of new ideas, but it didn't work. It was only fake. And because it was only fake, I live in a world which fake is no good. Everything we do has to be real. Everything we do has to function. And when you do something that's static, people don't trust it, they don't believe it. So I have to say that this is an interesting concept because we did display it. It looked very cool and very sort of pushing, but nobody, I remember at the show people were like hitting it and saying, it's not real, you know, don't believe in it. So, which was a great lesson to myself. Now I know that whatever we do, we have to make it work. We have to really make sure that below the skin lies the technology to make it work. And that's the thing that I think becomes more important, and I'll show you in a little bit later, is that I think that there's a real need for industrial design schools to link up with tech, to bring them together, because one side needs the other. And I'll show you some examples of this, because the tech side is really where it happens, but it does have to look the part. If it looks the part, people will trust in it and believe it. If it works, it's a done deal. And I think today these worlds are still somehow separate, and they need to come more together. This is maybe another little video clip, I don't know. This just shows you that before we do the actual designs, and the Steyr was inspired by the concept in the end. The actual production Steyr did become inspired by the concept. And in order to convince the company inside, we make these little videos of data, so it's just all math data. And this goes to the presentation to say to the brands that they will buy into the design. But it's a bit traditional. It's kind of normal. It's a nice tractor. I really believe it works. It's what it is. But if you go and ask design students, is that what you'd really do? I think they would do something different. So over the years, my team and myself, we've worked with various design schools throughout the world. And these normally tend to be transportation designers in a master's degree, where they've been designing a Maserati or a Ferrari or one of these Paganis, these cars that are completely useless, that don't have any meaning today, apart from the fact that they were cool. And we asked them to design a tractor. And the problem is they have to think about it before they design. So I watched them doing it, and normally they would be sketching. So they sketch the car before they think about what they're doing. So the idea, if you come to the world of agriculture, it's impossible. You can't do this. You have to think and you have to research before you can actually put pen to paper. So this was one of the designs a few years back. These were, it's a month and a half work of a group of 3 to 4 students. And we ran a competition, we gave them a prize. And later on, we also brought in a second company to help us. It's quite different from the previous tractor. Why? Because they're naive, or because they're not contaminated by being in the industry. And you can see also the importance of the brand, that it's got to be recognizable from a distance. You've got to have a symbol that people remember. But a month and a half before that, the guys who did that had never seen a tractor before. So that brings me to a year later when we decided to ask Lavazza, I'm based in Torino, and I know that south, it's a little bit different, and the coffee, depending where you go in the world, it's a question of taste. But I found it very interesting that Lavazza in Torino are well known all over the world, and CNH built coffee harvesters, but the two had never met. So I decided to ask Lavazza if they would be interested to be part of this project for young students, in which we ask Lavazza and we ask the students, if you were to design a coffee harvester for the future, what would you do? And they told us that our machines were much too big, much too expensive, and 80% of the coffee is manually harvested today in very difficult terrain. So it was incredibly interesting. We found out so much. So from a company point of view, I think we learned a lot. From the students' point of view, they had a wonderful time researching. And then, of course, they came up with their ideas, which are, in the future, they might happen. But things like that are, I think, they give inspiration. They give inspiration to engineers, to scientists, to designers, to say, what if, you know? And I thought a coffee harvester could be something more like a Dyson, small. And we heard it in the previous presentation. Compact, portable, affordable, modular, as opposed to huge machines that it's very difficult to afford. So I think it was cool. This was the key sketch picture. Okay. And then I moved to the next one. The next one is with Ferrero, hazelnut harvesting. So that was also extremely interesting. Hazelnut harvesting, we learned a lot. There are machines actually made in Alba, just outside Torino. They're kind of handmade specifically for Ferrero. It's a very difficult job because the hazelnuts fall off the trees. You can't harvest them on the trees. You have to pick it from the ground. So it's a big mess. It's not easy. I mean, but it was very interesting again. Ferrero were super, super helpful. They actually came to the school as well, gave talks to the students because they were so pleased to be a part of this. And it's funny because the ones with the cabs are the ones that look better, but the actual presentation that won was robotic, because Ferrero believed that the future was not in this direction, but it was in the pure robotic direction. This one. So, interesting. Then we moved to, from there, let's see, this is it. So this was the winner. And what was funny was the other ones looked cool, but they were saying, well, why would you need to do that now? Then we moved to a world of martini. Again, the reason for this is the school is in Torino, Istituto Europeo di Design. The companies that we partnered were international but local. So Martini Rossi is famous in Martini. If you ever have a Martini anywhere in the world, it comes from there. It's iconic as a brand. It's very famous as a sponsor to motor racing and rallying over the years. And when we went to meet Martini, they couldn't understand why we wanted to do this. It was like, why? And I said, because you do grape harvesting. You know, there is a reason, and herbs. So they got it. They came in and they said, yeah, we'll sponsor it. And so the project was to do the same thing, to do research, 1.5 months, to come up with an idea for the teams. And then also there was an extra in this one, was to create an iconic Martini poster. Because if you look through the years, Martini posters have been pieces of art, really. So this was also a given. And then it was bizarre because we were expecting to see a tractor type thing, and in the end we didn't. So let's see if this works. There you go. And there might be another one here. There's a few of these. But I think it's quite inspirational. I mean, they're quite naive, so because the people doing it, I mean, they're really students starting out. They came to design a Maserati or an Alfa Romeo or an Audi, and they end up doing this. And what it did is it opened up two worlds. It opened up to them the world of agriculture and construction, that there is a job there, that nobody knows that you can do industrial design for these companies. So it opens up a world for the students who previously thought there were only cars. Okay, I'll move on a little bit. Then I'll move back to reality. So reality is kind of what we do on a daily basis in CNH. It's combine harvesters. They're incredible. It's kind of a factory on wheels. For a designer, it's a little easier because there's a little more body work, but we really have to work hand in hand with the engineering because everything has to be functional. There's no place for style in the world of agriculture and construction. But nevertheless, it has to be memorable, has to be seen from a distance, it has to be somehow iconic. So we have this connected flow line now, which is running through all our New Holland machines. It had actually been done by a design competition through the different studios that we have from the USA and Europe. Then we have the Case IH Combine, completely different machine, completely different designer. And you can see down at the bottom, these are the initial concept sketches. And what happens is, as we do the design, the actual engineering is changing. So when we started the package, we call it a package, and say in car design, you're given a package and you draw around it and then you do your car. In the Combine, the whole project was developing. So it was a moving target. So we started very way out there, and then as we get closer, we get to the real thing. And then one day, you never know, you still got to have fun. So as we move forward, you don't need all the Combines to have cabs. You could have one with a cab and then drones going beside it that are autonomous. Or you can control it from the air. You can control it with a drone. But then, as a farmer, what you're going to do, you sit in your little room looking at the wall and your computer. Why don't you get out there? So you can come out there on your manned drone, check it all out, and then come back, because you still have to have fun. You still have to be part of it. Quad track. So these are just little clips of what we've done. This is the real world, which is much more traditional, but it's really changing fast. That tradition is really moving. We do our best to make the machines look good, and also because you need to be proud of them. And if it's, for example, if it's for a vineyard, often with Pininfarina, we did the straddle tractor concept for a Champagne region. And then Pininfarina were like, how can we make this look good? How can we make it cool? But they did. We won a design award through it, and it's really important because it kind of reflects the company that it's working for. Let's see, what's this? Nope, I'll go back, sorry. Oh, yeah. See if I can do this now. This was the design work for the new face of New Holland, because first of all we had done the combine harvester and the baler, and this connected flow line needed to somehow link into tractors, but how to do it? So LNG methane tractor concept. The sketches. Today, to be very honest about it, a lot of these sketches, they're not always done before, because we build so much now in data that a lot of the work's done in data. Then we use the data to do virtual presentations, because underneath that data we've got all the engineering work as well, and it needs to be all worked together. But then the creative sketching still happens in parallel. Let me just nip through. It gets a bit repetitive. And then I want to come back to Lecce. I want to come back to the area of Puglia, because we're moving now to close up construction equipment, radio controlled, remote controlled, and the idea that in construction equipment, and this is a fully functioning concept, it becomes more and more important that if you're working in dangerous areas, that there are not people there when it's actually working. If you've got earthquakes, if you've got problem areas, if you have to go into areas which you really shouldn't be there as a person. And if you would like to include, the example here is, this is not a control room, it's a control lounge, because you want to have a nice office, you want to feel at home, you want to feel comfortable, and that office can be moved close to the work, or it could be quite a bit farther away. And it also has easy access for disabled people, which is something that today in tractors and in construction equipment we want to do more, but it does have difficulties, getting in and out. And the idea of this moving towards remote controlled, moving towards autonomy, it allows a big inclusion of a lot more people who would previously not be able to have done it, and now they can. So these are initial sketches, and then this is the real machine. And this is how it can look like if you're inside near it. And that's it. I'm done. And Motor Valley Fest. We went to Motor Valley Fest in Modena, and we showed one of our T7 tractors. And it's funny because it was a world of Pagani, Lamborghini, Ferrari, Maserati, and New Holland. Because we have a factory, we do our engineering for small and medium tractors there. So we proudly presented our tractor next to these cars. And I have to say, we blew them all away. Okay, thanks very much. I hope it wasn't too long.
Thank you for making us dreaming. And now we have a coffee break to be awake, and then after this short coffee break, just 15 minutes, we can continue with the manufacturer panel discussion that is guided and moderated by our friend Carl Renius, Professor Carl Renius. Thank you. So coffee break, 15 minutes. Thank you. The coffee break is in the corner, near, yes. On my right, on your left.
Do you sit down here or there? No, maybe there is better because we move a little bit here just in order to. Yes. There.
Now to test the slides.
Vedo.
because it's still there because
Okay,
you have video embedded there. Only
Only three
slide.
slides. Only three slides.
Okay. It's not mine. It's not my computer, so.
COB bounding. That was already.
This one?
No. The first one.
Is this?
Yeah.
Okay.
On the screen.
Yes.
How to shift? Okay. Okay. This is the first thing.
I don't know why they were to. Anyway, it's okay. I have to remember to transfer to laptop because I need.
Just willing to meet you in person before, but if you can associate with anything. Yeah, it was normal sometimes I didn't observe it. Yeah, but it's Bologna, kind of Japanese. It's another. I can try to say something, but I know something. I will try to say something, but it was not discussed, but it's okay for me. Okay.
Because that was a patent from Kubota. Highly discussed at the time. I was in Japan. There was a large
Yeah, I know what you mean.
was, I don't know, the early 90s, late 80s.
The project is in yeah, but this speed now is really super. I know this speed. Sometimes it's very popular in Japan. It's a pretty good.
Are you ready to squeeze these guys?
Try to be careful not to overload you because my knowledge is everything. Also,
We will help each other. We will help each other.
we will make it in a way that first we have 3 representatives. Take my manuscript.
Change the order again.
Standard practice in general, around that everybody can answer a question. So that means one is the first, of course.
I'm working on the. Okay.
So I consider it as possible as possible. Your wishes.
So as long as you don't make me talk about transmissions. Take it. Lovely.
We will be almost operations, soon breakthrough or still need. I think you can say later we can go to in a second round. The second question will be
I can also say something.
everybody 5 minutes in the first round.
I'm innovation. I will invent something.
No discussions, only short answers.
Short, okay.
Because it's possible 4 to 5 minutes.
Not triggering additional.
Otherwise, we have no time for a second round. And the second round will be both Robota regarding the return, because for return there is the gold medal, technically the highest award worldwide on a vehicle which, again, presents the return. Gold medal, we know what it
There
is.
was not even in. I will say something. Don't worry. I'm Italian. I'm used to not the best version, but I will say
If we can jump in.
That's
So
okay.
if Fed presented a new practice, you see, but the gold medal goes to this company.
When was it? Which year was it? In which year did they get that medal? This gold medal, Kubota.
Kubota, I didn't get it.
That's what I meant.
No. This is now, this is here.
This year, the 10 track.
The only gold medal will go to the Swiss company. And this is the innovation which was developed together with Professor Gallman. It's very interesting.
It's more on the movers, but
Very interesting.
say something.
This is the third approach. Kubota was the first, then Fen came, based on 2 dissertations from my institute. And one of these guys became manager of transmission of Fen and realized what his dreams were in dissertation. And the third is now this gold medal, which is going to a small company in Stuttgart. And it's a cooperation with the German Institute Karlsruhe. So very important. It's too, in my opinion, it's well done, but it's too expensive for a mass production. It's more for Alps regions where you have different requirements as compared to Germany, Germany. But it's won the number one award worldwide. Gold medal. And since some days it is public.
So what I can support the alternative fuels, if you like. The first question here, if you like CNAs, I can support. I can talk a few minutes. I don't see any name.
Reserve.
Okay.
It's stressful, but
It's a fast.
I've been once in Manhattan for a week, 1 week, so I can't say much, except for we saw the important places and left it.
if you come with some time,
Second law is
give you a list of things to see.
return. You can make it short. You see, you can make it short. Yeah, you can make it short. We are working on it. Okay.
I would say so.
But you should know that the gold medal is going to a new concept which realizes perfectly. They can control the speeds of all four wheels by driving the ring gear of the final planetary forward or reverse with a hydraulic motor. Which is incorporated.
They have almost 4
This is of course not cheap. But it is well integrated so that the costs are not so high. But in my opinion, for general production high. So next will be
Then on the bullet turn, I have a question for you, just to...
wireless implement control. Wireless implement control. I give this to Echo. Because Echo has information which will be presented. I know all applications to the awards because I am a usual consultant to the DLT team which is deciding. So I'm well prepared what will happen on our So Echo will present
The discussion.
It sounds like, but
Can I on the bullet turn?
am I allowed to ask to get also?
I was the one saying no future.
There was advanced research 10 years ago in Dresden, and they found that has no future because you have only two ranges in if you put it every wheel electric in two ranges, it's expensive.
Probably not needed because of it is an open field.
Motors are very large.
And the
So this is no more of this. The trend is electric. For the drive and another one. There are so many other solutions that I think this is
Maybe on small tractor you may have the front axle controlled electrically if you need maneuverability. On the small tractors where you need high maneuverability, but certainly the central.
This side repair.
The setup is strange in general. Panels should be
then you need much more power. Because for front-end loading, you have some, for 1 second or so, full power of the engine on the front axle. So you have, must be mentioned, the motor for the front axle for 100% power.
Yes.
Because for a short time, it needs for front-end loading.
Even if the load distribution can be 60-40,
That's
but
also
you
what
need
we
to
are
size.
suggesting in instrumentation, that for front-end loading, it's very specific. With influence design. So, okay. And then
But it's also a question of do we have the electric according to
Nice to meet you.
Nice to meet you. That's the advantage of the IDT transmissions today, that we can keep the, we can control the ground speed and concentrate with the engine on the PTO. Yeah.
But this is, of course, efficiency is not as good. But I think also in the future, the tractors will in many countries sold by PTO power. This is still the situation. Well, so you agree? Yes.
We will make it. We will make it happen. Let's.
You've lost the
You're already here.
Yeah, we agreed.
He gave us the answers.
Ah, that's good. That makes it easier. Teleprompter.
Well, I know the innovations which were presented on Agritechnica, so that's very good information.
Sorry.
Right now.
Maybe you need to present more and we are just asking questions.
But it is more life, you see, if from the companies are comments. I expect also some comments which I lose.
Let's see what comes to mind.
Yeah.
Okay, it will be a friendly conversation.
I will try my best.
Underneath this, we keep our legs.
No, this is your role, not my company.
The beauty of our industry is, on engineering level, we are friends. On marketing side, we fight for market share. That's the beauty of our industry.
So we are in engineering
He
here.
is always very smart. Discussions.
I'm not sure.
A few days ago, I had a meeting with former Pence, and he presented the future. How he is seeing
Why is he not here?
Because he's retired.
Yes, I have more time for that, of course. And it's very smart. The style was very smart. But the politics and personal hiring and firing, I don't agree to the politics of Germany right now.
You come easily into
Politics of companies is a waste.
Yeah, even he is not understanding that.
you quickly end up in a discussion about the whole social and economic system. I mean, we talk farmer first,
Big
but
companies like the tractors manufacturers need to see, need to have a very close look to investors.
and it's almost investors because the stock goes up if you fire people, right? Crazy enough.
The sales were reduced by 100%.
For example,
So
Tottenham was
from
acquired
60
the
billion
they changed it completely. They will not have a good Agritechnica. They changed it a
and
lot.
they want to make the same profit.
That's
If you want to make the same profit, labor
Since now
costs.
they need to make money, they stop at everything is not really money oriented, not the best approach, let's say, because we will maximize the next 2 years and then
Really happy.
Yeah, that's like with the sustainability discussion. There's always a price you pay.
Okay, let's get
coffee for me, please.
How does the power of tractors today?
Yes.
Bigger. You see so far, we still see bigger.
But there must be a limit somewhere. There must be a limit on the increasing of
We heard at least in Africa they need small flexible units.
Like India, like it's always the same.
also because
Easy to
Yeah.
maintain.
then the soil, I mean, you can find a smart way to distribute the power, avoid soil compaction, but
Yeah, but you can't completely avoid it because there's always the deep sea compaction at the top. So the ground pressure does not equal deep compaction. We just had a study from our agronomy farm. They had it's not new, but how many tracks do you lay all across the field and how much percentage leaves open?
touched. The rest travel across. And they measured 9% only crop cycle. They said 16 bushels per acre yield difference on these 9% versus the rest of corn. And that's about 1 ton per hectare yield difference. Yep. And I said that's zero touch, that's almost like if you're flying over field. That's not like possible. But there's something in between where you say maybe a 300 horsepower tractor is then easier than a 30-ton monster.
But that's the argumentation for Australia with the control traffic. Why they are so picky. And I'm also convinced with also when our tractors get bigger and bigger still to squeeze more out of the operator, more efficiency or productivity, as you say. I think with autonomy, we will rather sell smaller ones, also when our companies don't like this. Our money with the bigger ones.
Margin is better, exactly.
But we just need to make more margin than on the autonomy package. Maybe we can compensate.
You can compensate.
That's probably not the topic here.
But we can debate.
That's a political thing. You get a question, but you answer a different one. What I wanted to say.
That's why I asked, do we all get a microphone? It's apparently only one. Since here and there, I think it would be cool to say something. I still dream of discussion instead of.
But that's what we do anyway, like right now. Right? I mean, we create the value, just the rest doesn't hear us. I think.
Sorry.
But are we sitting?
If possible, please
we are here. Okay.
So the whole setup is strange.
Interesting.
go to our places and start with the next speech. Thank you. Thank you.
That's what people say. But it was always like this. Ever since I'm here, it was always like the last 8 years. Maybe.
Okay, thank you.
Was this another one?
No, but that's interesting.
So is your escape? You can escape. That's cool. Actually.
Hello.
Hello. Hello.
Ah.
What's the best?
Okay. Please try to start because we need also to have some space for the questions and answer by our speaker. So I leave again the floor to Giuseppe. Giuseppe.
Thank you. Thank you again for your patience. So let me introduce the next presentation. It will be about the technology as a driver for the future tractors. And it will be actually a panel or 4 representatives of manufacturers, John Deere, Kubota, CNH, and AGCO. And the moderator and the person who will ask the questions and coordinate the discussion is Professor Carl Renius. Carl, floor is yours.
Thank you, Chairman. Can you hear me? Yes. Well, thank you for this invitation. I will try to do my best to run this panel discussion, and in the first step to present the colleagues which will discuss with us, with me, mainly giving answers to questions. That is our strategy, which we have prepared by some internet meetings. And we have here in alphabetic order Benno Pichelmeier, on the right, then Stefano Fiorati, closer to it, representing CNH, here. Then Hans-Jürgen Nissen, John Deere, Manager of Solution Control Strategies. The other options you see there, I will be repeated. Pichelmeier is Director of Global Research and Advanced Engineering of ECHO, and mainly Fendt, but responsible also worldwide for this area. And Stefano Fiorati is Director of Powertrain Innovation, very interesting subject for me. And Hans-Jürgen Nissen, I mentioned already, manager solution control strategy, an expert in management of tractor and implement too. And the last one, Fulvio Sabino from Kubota, is chief engineer in precision farming and has many patents. I have seen in the internet you have a very large list of patents. So good to have you on our meeting here. Well, our strategy of the panel, you will see in the next slide. Yeah. We will discuss 3 gravity centers, standard tractors in general, standard tractors improving existing technologies, and standard tractors full electric generation 2. And I thought it would make sense to summarize again the needs and the key drivers in tractor technology. To summarize, many are already mentioned, and we concentrate more on high developed countries and exclude countries like Africa in this discussion. So, but many of the needs have general also for Africa. Labor costs, for example, in my opinion, number 1, driver, practical needs, of course, we have seen in the presentation, very good structure of needs in Africa. Then also labor shortage. For example, in Japan, they apply robots even if the costs are increased because they have no people. Dealer quality is in Europe a very high driver. Technology progress, of course, also. Riding comfort, subsidize, energy prices, CO2 costs, laws, regulations, and standards, also important. Tax. In some countries, the tax dictates the future of tractors. Environment, climate change, robots as competitors, perhaps. Self-propelled machinery, everybody knows that, as also a certain competitor. Well, now we would like to go in these 3 blocks. And I prepared a little bit the questions to compact the time also that we do not use too much of time. So my first question is going to John Deere, of course, of course. We must do, because John Deere sales are, in this year will be 50 billion US dollar, and perhaps another figure. I have tried to research the sales of tractors worldwide, and official number is not existing, but the average of all information I found is 80 to 100 billion US dollar. So that's a lot, only for tractors worldwide. Now coming to the first question. We have seen a lot of recommendations to autonomous operations and robots. And my question is to John Deere now, will we see a soon breakthrough or still a niche for standard tractors? Please.
So that means then it's me. The answer is maybe. We heard it this morning that labor shortage is an issue globally. And if this autonomy is a breakthrough and when it is really depends on the region. So we see different pull in different regions, or should I say different hesitation in certain areas. And we see in the different areas of our crops, I want to say. So high value crops where the money is available, they will get earlier into it than, let's say, corn and soy or something. And then the other thing is, of course, the same as we have seen with guidance solutions in the past. So 20 years ago when we came out with that, first the farmers with large fields, with appropriate money available, they got into it, and in the meantime it grew into the small farms, right? It's a given for all of them. And I expect the same to happen with autonomy.
Okay, thank you. I would like to add that Marquardt von Pentz, who was for about 20 years president of the agriculture and agricultural machinery section of John Deere, he said a few days ago on a meeting to me that the profit of John Deere on added automation and added precision farming devices, the profit on all these things is now, was not all the time, is now higher than for the machinery itself. This was surprising for me because I didn't know that. I had the information that the companies had problems with costs to develop these things, but now it pays, you see, and it pays better than the machinery. So this is an interesting trend, and this is, of course, a good trend in my opinion. You agree to that?
So the digital solutions, so the complete package you deliver to the farmer, that is the answer. Yeah. It's not only selling iron, it's these days delivering the automation, delivering the back-end solution that you deliver a complete package and not only a tractor or an implement or a combine. So yes, I fully agree.
He was analyzing in this presentation the whole scene, you see, as you mentioned, and I fully agree that this is the future. This is the future, and I could make some comments more, but we will go to more questions first. The next one is to echo. Have we any limits in increasing the power, the nominal power of tractors, of conventional tractors?
Yeah, that's a good one. Also combining to what Hans-Jürgen said onto the question of autonomy. There's no engineering limit, so we can build larger machines. I think that is not a problem. There is, I think the discussion is almost as old as mechanization. How big will machines get? At the moment, we still see the growing trend of the specific costs of operation because the operator cost, the labor cost is significant, and the logistics to manage smaller machines is higher than have one large machine. So the continuous trend, I would say, at the moment exists. However, there is also significant potential if you look at these other technology trends like autonomy and electrification to enable different types of machine and logistic concepts and change the cost structure of operation. So if you take the operator out of the equation, or at least a certain relevant percentage, the trend line kind of pivots between larger is always specifically cheaper or more productive versus towards more a medium-sized machine which is easier to handle. Just to give you one example, large implements are overproportionally higher cost than smaller implements. Higher intelligence on the implements per meter is higher cost. Also the mechanical design, the structures, the possibilities to fold the machines, it's all very, very intense. So if you have autonomy and high automation available, I would definitely see that there is at least a stagnation or a rethinking of that trend towards medium machines. As we have experimented with the other extreme, like small robots and machines, there is no buy-in from farmers, almost zero. That is like you lose the customer. That's too disruptive. But the medium size, typical contractor machine in Europe, 300 horsepower versus 900, I think if you get to more automation and autonomy, there's very likely a growing market in that area.
This is very interesting because since World War II, the power has continuously increased. The same with airplanes. But the A380 shows the limits. You see, because it's interesting. I investigated a little bit the reason why this is not so successful, this airplane. And there are some similarity laws which are against larger airplanes. So the Boeing 470 was just right, still just right. But to make the airplanes larger, you get problems with some similarity problems. And if you see the landing gear, you see how complicated that is, and some other things. I will not go in details, but it's very important to look for similarity laws. And also regarding for diesel engines, the air transfer. Today a tractor is a sieve, you see, the complete hood is almost a sieve. And 50 years ago it was a small window with a sieve. So there are similarity laws which should be considered. And almost nobody is now doing that, but it's not unimportant.
If I may add, I'll try to explain something that I also learned in my history, also at TU Munich, and thanks some of your previous PhD thesis, these laws of growth. It's a simple example. If you look at an old tractor, why does it have so narrow wheels versus the new ones? And if you look at, for example, a tractor that is a 2.5 meter length tractor and a new one is maybe a 5 meter tractor, so a factor of 2 in scale means that in terms of weight, it's a 3-dimensional growth. It's 2 times 2 times 2. So we have 8 times the weight of that large tractor, but the contact surface of the tires to the soil is only a 2-dimensional growth, length times width. So that's why you have this overproportional growth of tires, and all these efforts we try to keep the ground pressure low, and even the lower soil structure pressure is not directly tied to the contact pressure, but is always a compaction issue because it's directly dependent on the weight of a machine and not on the contact surface. And we just received results of a study. I mentioned it to my colleagues of one of our research farms, where they were growing corn and analyzing how much of the surface area was covered with tracks around the year. Things like that have been done, I think, as well in the UK, in, I think, Harper Adams, they have in Australia. But anyway, so 9% was the result, if I remember correctly, of the field was not trafficked by any wheel from a machine. And the difference between the trafficked and the non-trafficked in yield was 16 bushels per acre corn, which is roughly 1 ton per hectare yield difference between zero compaction and machinery traffic. So you could tell that somewhere in the middle there must be also a real agronomic benefit that you can explain to farmers about not growing further in weight and size.
Well, thank you. I fully agree to that, and I would like to add that the costs, the relative costs for a tractor for the wheels is increasing, you see. 50 years ago was much lower than today because, as he mentioned, the sizes increases over proportional to control the contact, power transfer, and soil compaction.
So, but today we try to squeeze as much as we can out of the operator. And when we can eliminate the operator, we can downsize the machinery again, get less compaction, get
of course, there are a lot of
more flexibility out of the system. So when one large tractor breaks down, the whole system breaks down. When you have 2 smaller ones, only 50% breaks down, right? So there's multiple arguments.
Possibilities, but even still regarding these possibilities, the tires are a problem. See? So one reason, one solution was to increase the speed of operating the tractor, but well, this is a large discussion itself. We continue our strategy, and the next question goes to Kubota, and there I would mention what the background is. In the late 80s, Kubota had got a patent on the B-speed turn. This is overdrive for the front axle to improve the turn in the field. Today, most tractors do not use in the turn the four-wheel drive, you see. This disconnects the four-wheel drive automatically because the four-wheel drive, the conventional four-wheel drive is braking in the turn, and what we want is to pull in the turn. And so in my institute we had made two dissertations on that, and one of these guys realized in Fendt company a solution which is now very popular, but the initial input was Kubota in series with the B-speed turn with this overdrive. And this is in Japan. I saw it in Japan. It's very popular and still used. And my question to Kubota is now, do you proceed? Do you consider or prepare another solution which is infinitely, because the B-speed or the pull and turn technique of Kubota was only one step to give more speed to the front axle to get a better pulling in the turn. You see. And to add one important information on Agritechnica, in 1 month we will have the Agritechnica. The highest award for tractors was given to a small Swiss company which developed another pull and turn solution together with an institute in Germany. And because the Geimer was the main drive behind that. So as this is a certain time, we talk about technology development. So this is the next step with the highest award worldwide. The gold medal of Agritechnica is the highest award worldwide which you can get for an innovation. Yeah. So my question now again, what's your situation now? What do you think about that?
Yes, we should firstly say that this solution, the B-speed, that is currently...
Louder, speaking louder.
Okay. This solution that is normally available now on Series 5 tractors was developed in the past when 1/3 about of the revenue of Kubota was coming from Japan and Asian market. It was developed and it satisfied overall the Japanese needs, where you have very little fields and you had an advantage is this reduced the turning ratio. It satisfied the requirement of the time, and currently the function is properly working for the needs of Japan. There is not any future plan to expand it. That doesn't mean that there are not some internal engineers working on the topic, but in the mindset of the corporation, since the physical need of the Japanese field was fully satisfied with that solution, that is gone. It could be further developments for other needs that today are still not on the table for us in Kubota.
Okay, that's also what I hear in Germany. And paddy fields, you see, in paddy fields, you can also give an overdrive with a high speed, which will not be accepted in Germany. If you give him 50% or even more additional speed, that will not be accepted in Germany. But paddy fields is a solution.
That's
and the reason that it's still... Well, another question to CNH now. Thank you for your answer. Well, you have done a lot, advertised a lot on improving, taking care of the customer, you see. So my question is, dealer services, what can still be improved practically from your side?
Yeah. In fact, the customer is, I believe, we can all agree, is the core of our development. We want to develop something that makes the customer in the position to do the job in a decent amount of time, because we don't have to forget about the shortage of time windows due to the climate change related to the possibility to perform the task and so on, and connecting to what was said before with the upcoming of automation and autonomous, and also I would say electrification, we will have more and more data available out of the machine. And this data definitely can be used to adopt or to implement a sort of, I don't want to call predictive maintenance, but definitely self-diagnosis of the machine that can tell in advance that something is going to fail, and in this way you can plan the infrastructure, you can put in place the infrastructure to plan ahead the replacement of certain components, and this definitely will have a benefit in productivity, because the downtime will be directly attacked, and I think this is important, and this is a step of improvement that can be done at the dealership thanks to this technology, automation, autonomous, as well as electrification.
Okay, thank you. A practical question. If you sell a 200 horsepower tractor, which percentage of customers wants a remote service connection and also exchanging the data, you see, because the customer must agree. What is the percentage as an average?
I would say maybe it's not 100%, but it's very, very close, because the 200 is basically a size closer to the big farmer, where they want to have a control of the fleet, and that connect to your question. They want to have that control on their machine, because they have such a big fleet that need to go in the field and work, and they need to be monitored. It's the 200 horsepower is the borderline, let me say, but definitely.
Okay, let me go to 300.
300 is even growing the percentage closer to the 100%, definitely. Because
100%.
Not 100, but 80, 70,
okay,
80%
okay. Well,
for sure.
That is very interesting.
It's really interesting because.
Very interesting answer. Because the forecast was years ago, will it work? Will it pay?
But if you consider that the 300 horsepower is the typical tractor of the professional, exactly, and the typical tractor of a fleet of tractors, there is a need of controlling those machines, and there is a growing interest on that.
Okay, so that was the first round. You would make a comment to that?
There is another very important factor overall for the OEMs, that is the location of the tractors. We have tractors at 3 hours from the closer dealer, and to go to visit that tractor means 1 day just to go and to go back. Then you need to take a log, then you will go back. 10 days to get the tractor repaired.
This is important. Really, I can understand that, and this will increase. Rather increase than decrease. You see? Rather increase than decrease. Well, this was a good first round, and I hope you all agree to them. A first acclamation would be. Now, the second block is standard tractors improving existing technologies. I would like to give a first question to you all in very short answers. Which fuel do we need in 2035? Which fuel for tractors will we need? Very short answer, please. Very short answer.
There's no a single solution.
Not a long...
No. There's no a single solution. We need to look at the country by country. Just a very example, Brazil ethanol, Europe there is no ethanol. So there is no unique solution. My short answer.
I fully agree. There's no single answer. It's ethanol, it's biofuel in Europe, and diesel is still the baseline.
I do agree with them, but we should also say that there is a big difference between municipalities, the center of the towns, and the far fields. So there we can have also different kind of fuel like batteries or electricity.
I think the question was which fuels or energy sources we need. I'd say we will need electric energy, and we will need sustainable drop-in fuels, liquid for diesel.
And would you agree that 10 years later from now, diesel is the most used fuel?
In percentage, I would...
In percentage?
Fossil diesel, you mean?
Yeah. No, diesel engine.
Liquid diesel engine fuel, yes. Okay. In 10 years from now, yes.
Kubota has tried to come into the market, very successful in mid-Europe. So my question is now, what about the regulations? Did you have major problems with the regulations in Europe as compared to Japan and countries like that?
Obviously, for a Japanese society or OEM, European or Western regulations are very strange. So in the beginning, they were completely lost. This is also why Kubota acquired Querner, that was another distributor already present in Europe. With mother regulations, so mainly belonging to the engine, it was not so challenging. But I can see, for example, for CRA coming in 2027, a lot of challenges, because this regulation is mainly for the software, and in the past it was mainly for metal an engine. So also the mindset of the people have to be changed. Normally in this kind of societies we say if software had the weight, it would be more considerate because these are metal companies, you know. Now it's the moment that people are changing their mindset. We are going to change architectures. We will be forced, I say we, not only Kubota, because we know the situation, to change some parts, to change some accessibility to the architecture, and also to better manage the software releases. So,
Okay,
CRA, yes.
My compliments to you that you have a good guy since many years already in the TA1 committee, which is working on regulations, which is trying to get the regulations on a reasonable level. You see?
Reasonable, it's the keyword.
Reasonable level. So if they would not have done this very good work, we would have a higher level even. But now we have for tractors the strongest level in the world.
One of the main challenges was also to explain to European Union that tractors are not, it's not automotive, because some people are really mixing automotive and tractors.
But automotive requirements are not higher regarding engines, are not higher.
Not
Trucks
engines,
is
but
comparable.
for CRA, for example, there are really stronger requirements.
Okay. We are still already in the block 2. And there is another question to echo. Wireless implement control. What about that? I heard something that something will happen, but I don't know details. I will not say more. So you can say what you are allowed to say.
What I'm allowed to say. I mean, it's an engineering discussion, right? So of course we can talk about that. I mean, there's one thing is that we always, all speaking for ECHO, try to comply with a standard and follow a standard that's established. So ISOBUS, for example, all levels, also other types of information transfer, like currently working on the AG-IN network or on the machine-to-machine direct connection solutions, but always trying to find a way how we get to comply to a standard that works for everyone. And I think most of the folks, and I think the group here, we discussed a bit about it yesterday, agrees that this is the highest value because we open the market and the farmers benefit from the opportunity to combine and connect machines, and we all win with that. The wireless technical solution, I would not be so worried about, but the priority in making it a standard varies, let's say, so it's coming and going, so I would definitely not be able to tell you a year. Maybe Hans-Jürgen has some additional thoughts on that one, when it will come. What we are working on, and what is definitely something that we also, speaking of automotive, coming closer to a standard, is Wi-Fi V2X, so safe direct machine-to-machine communication, and trying to solve that one also in accordance to on-road machines. That is also one of the solutions that will be promoted, shown at Agritechnica. But wireless in-field communication, the WIC group, right, exists. Hans-Jürgen, you want to add something to that, or read your glass bowl?
So first of all, machine-to-machine communication, that means combine to grain cart, that's something what we have for years in the market. Forage harvester to the tractors running beside it, that's something what we have, and that's the focus of the WIC group, or one of the focuses of the WIC group in AF. Since as much as we like green fleets, in particular here in Europe, we have some farmers which anyway buy other tractors. So there must be a reason for it, but that's good. But you asked for, in particular for wireless implement control. That's something where I can say John Deere, we are known for being an American safety paranoia company. There's a no-no in our company. Yeah? So implement control, no way. But data collection through the wireless world, that's possible. You have broader data ranges and so on, but you're also more in the area of perceptive for interruptions of whatever disturbs your wireless connection. So
very interesting.
We believe in rather in high-speed isobus, in Ethernet, cable connection, so since you are not so much disturbed by other wavelengths and so on.
I definitely fully agree, also because we are going in the direction of exchanging more and more data between tractor and implement with the scope of having a better controllability. So I definitely fully agree on this point.
Okay, that was very interesting for me. So we can go to the last block, the future. Standard tractors, full electric, generation 2. And I would start that also with some personal comments. If you see the situation today, almost all companies have done a step to replace the diesel engine by a battery with 1 or 2 electric motors, and not to modify or almost no modify the rest of the rear. So this is understandable to test the reaction of the market and to limit the investment in development and design development of the company, because it can be very costly to make a completely new tractor. And all these solutions have some interesting points, but there is no perfect solution right now in my eyes. So my feeling is that we will need a generation 2, and it's also very clear that large tractors have no chance. And I would like to mention 2 publications on that subject. One is from Dr. Pichelmeier and Director Al from Fendt. They have presented recently the most recent ASCBE lecture number 45. If somebody is interested, I have a stick with me, or Pichelmeier has probably also a stick to give you that. It's very well done. And I'm very proud that we Germans help ASCBE to get this lecture series running, you see, because in the US they have some problems to get good authors for that. And excellent. So I can recommend that. And another, some results, that tractors are divided in 3 groups. And the smallest one has about 40% average power use, the mid-size about 60, and the larger, very large tractors about 80. In my opinion, it's still a little bit too much, but about that will be true. So that means that the size of the battery, according to this, must not be proportional to the power, but over-proportional. And another fact which is mentioned is that a small tractor is perhaps used 4 or 5 hours a day, and a very large tractor can be used 12 to 14 hours a day. This again increases the needed size of the battery. And these two trends gives as a result that for large tractors makes no sense. And where the limit is, we don't know, maybe 120 horsepower or something like that. So this is very interesting. These figures are very interesting. And another figure was given to me from Pence these few days ago. Is the space for battery is 14 times higher than the space for fuel. 14 times higher. Yeah, this is also an interesting figure. But a second publication was coming from TU Munich, from Institute of Automotive Engineering. Also an interesting study which concentrates on the solution which with electric engines on the front axle and the rear axle, and he calculated the costs very much in detail and very seriously. Not the optimistic strategy, a realistic strategy. And the costs were so high that only with subsidized and special tax conditions and so on, it would be possible to make money with such a tractor. I have also this publication very recently, some weeks ago, which is done very good also by a guy which I have educated in tractor management, tractor engineering. And he will make his PhD thesis in that institute at TUM. So I have also these publications on my stick, on my small stick is still here, to have the picture here. So this was the introduction. Now to come to the questions. Which are the critical points? I have already mentioned some. Which are the remaining critical points? Is 800 voltage a must, as it is meanwhile for cars and trucks? So, who would like to answer that? Pick them up.
Yes, I need to say something now. Yeah. I would say it's a must in the sense of we have had a long discussion about standardization as well, about these interfaces and infrastructures, because our machines, and we're talking about future perspectives, are supposed to provide electricity as well off-board to implements or to deliver bidirectional charging and other elements. So if we don't agree on a standard, then we have a mess in the market. So we have agreed on a 700 plus minus volt standard to offboard that power, and even a physical interface and some communication needs for that. So we definitely should stay with that range. There is for sure some niche markets also of different types of vehicles that do not connect to implements, for example, where it is today, I would say, more cost efficient to go with still large volume components of a T2, 3, 400 volt space. But I think that will change quickly as automotive with the battery charging systems has so many benefits of the higher charging performance and the lower copper weight that they will go 800, and that will be the commodity sweet spot, I guess.
Oh, thank you. That was clear. Yeah, well, CNH is now. You get the next question. Then you
can I compliment to Benno first?
Then you can put in
no,
that.
I mean,
because the next question is, what is the structure of the powertrain? We have three possibilities: central, front axle, rear axle, or every wheel. In my opinion, every wheel is out. Front and rear is out because front end loading requires so much power that it's so expensive. So in my opinion, the central solution is the solution of the future. But please, what is your position?
Yeah. Definitely, yes. If we consider the cost of the application, the central solution is the best. Of course, we don't have to look at the electrification as a mean to just put power to the ground, but we always have to remember that the tractor has to be connected to an implement. And so it's important the way we distribute the power. And so here the electrification is going to offer a degree of freedom. So we can have also the PTO driven by an electric motor, having a sort of traction driven by the electric motor and PTO connected to the engine, having this decoupling between the two functions that will certainly help certain aspect of the automation or something like this. So I think it's important to keep in mind this aspect and just to complement to what Benno was saying very briefly, there is also the low voltage that we need to consider as a voltage level, not only 800 volt, but there are functions that can go also in the low voltage, right? 48 or below 60, in any case for those functions that are not power demanding, but they need to be controlled very precisely. So that there is also this other level that plays a role.
So I conclude, all these four gentlemen agree with my proposal to have, not?
I try now also to bring a different perspective in. I mean, we had our challenges because when we brought the E100 Fendt electric tractor and it was explained that it has a central drive plus a vario transmission, internal folks as well as external said, you guys must be stupid. So we went through our valley of despair explaining why we did this, not because we were stupid, but because of very practical reasons of cost, of the structure of the frame, of the PTOs and drives of that. But that is for sure the first generation. If you need to redevelop a complete tractor with all structural main components and everything, I think there's definitely a value to split maybe into axle drives. Automotive does that. Trucking has tried that as well, is going this direction, because there is beyond some of the fancy features, there is also like packaging benefits. if you need to get more energy onto the machines, we need to change a bit the packaging and setup, and that is a benefit that can come into play if the costs are really commodity prices, if electric motors, inverters and stuff are not like the big driver anymore. Wheel drives, from a traction perspective, I don't see much of a benefit, I agree, because you know, synchronous drives, we mostly go straight in high pull applications, and if you go turns, then you usually don't have the implement in the soil, so you can also then adjust and distribute the power. But somewhere in between is as well reasonable thought for the future, 10 years out or something.
Well, that was perhaps, has anybody to make a comment on that still? My concern is that you need 300% electric motors for rated engine power. So this is costly, and the inverters again to that. So I don't think that it will pay. You see,
it always depends also on the way the tractor is used. Like you said, that there are small tractor, medium tractor, and big tractor. So high value crop, small fields, high maneuverability. Big tractor, cash crop, they just need to go straight and they do not need maneuverability. So already this will bring a different dimension to evaluate the architecture. So,
okay, the time is over. So many thanks for these four gentlemen who had good answers, of course, I think. And I would like to give back to the chairman.
Thank
Chairman,
you.
Was that okay, how we handled it?
It was very much okay.
Yeah, okay.
Very interesting points and a good material for thoughts. So in the sake of saving time, I would like to limit the questions to just a couple of questions on section 1, because I would like to encourage people to interact freely during all the time that we have in these 2 days with the speakers, with the presenters, and exchange ideas. So we don't have time for a long question and answer sessions, but if there is just a couple of quick questions from the audience, of course they are welcome. Yeah, Randall? Yeah?
Thank you to all the speakers, in particular the four members of the panel. I'd like their opinion very quickly. Our first speaker today talked about the developing nations and the sort of market. If part of the market for the modern tractor is its second-hand value is based primarily on its export market, which is often to these developing countries. Do they, as companies, manufacture any models that are specific to the developing world?
I'll start very briefly. The reply is we are thinking yes, because of course I was listening, and we need to provide a very basic tractor, but with a certain level of automation. And so we need to combine these two aspects in something that is suitable for that market. And it's not said that the second-hand tractor are in that direction, are going that direction. So yes.
So from the John Deere side, we do have factories in India, in China, in Mexico, with specific products for those markets, as we saw them described here this morning, with increasing tech on it, but easy to maintain, easy to repair as the first focus, and then over time they grow in terms of functionality on it.
Also on our side we have local factories, but a lot of times overall for growing market we get requests and we say, this is exactly the project that we closed in 1982. Let's recover it. Obviously we cannot have the same materials and the same components because there are different logics, but we take a lot of old projects and sometimes we restore them, and they're perfectly fitting with the requests of the growing markets.
Yeah, the same. I don't need to add. And we also have factories in other regions and build machines also for emerging and low-cost markets. One thing to add was I found very interesting, and I heard it today, that's why I reference it, when we presented this small first generation of a field robot at the Hannover Industry Fair. We thought we will get fancy discussions with high-tech countries, but the ones that came and had most discussions were African and Indian representatives because of a small, lightweight, easy to maintain machine for small fields with the opportunity, what we heard, to leapfrog and say if connectivity is there, a simple electric motor and a small helpful tool, almost like a one-axle tractor, is highly interesting. So we were surprised by that.
I would like a final comment to African policy, shortly. We talk about the needs since 40 or 50 years, and we have seen the progress is zero. I made an idea, I presented an idea several times in the Club of Bologna to found Institute of African Technology. In Far East, they have been very successful with such a strategy. And if VW put so much money in to develop a tractor, FAO should catch them that they finance such an institute, African Institute of Technology. So this is a huge target to try to realize that for education, because education in Africa is extremely poor. Education, pooling all activities, making research and contacting companies outside of Africa for special questions. So again, today, as a consequence of your presentation, try to get this done. And then you will get an increase of mechanization with tractors. I am very sure that this is possible. Thank you.
Okay, one more question. Sorry, just one second.
Thank you for this suggestion. Just I would like to inform you that for the moment we are working on this project because we have one conference in Tanzania in November, and one of the very important topic of to create what we call it center of mechanization, as it's in Asia. You know, in Beijing they have what we call it CISAM, and now we are working to create one CISAM for Africa, which covers all what we said: training, also standards, testing, and other things related to mechanization. That's for information. Sorry again? This is a project we are working on because they need funding for sure. There's partnership, and we are looking also for okay, this is what. Yeah, but you know that there are already some centers in Africa. I know, for example, in Tanzania there is one center created by JICA, but Japanese cooperation. But maybe there are others. So I think that is. I am fully agree that is maybe the best way to develop mechanization. Okay. Thank you.
Okay, thank you. Please.
Thank you to the speakers for presenting. I just want to go off the previous question a little bit. When you mentioned about the localization of automation, so European versus American versus African versus Asian, there's a bigger context around the ecosystem. So what does the surrounding ecosystem allow you to do? So even though you might have small electric tractors that could work in Africa, and even if you might have the communication, the surrounding socio-economic capabilities are not there. Can I just get some thoughts about what that might look like from your perspective as you move forward? Automation in a Western country will be very different to one in a developing country.
Certainly one of the big task is to work also with the local government, let me say, on creating, showing them that there is this need, showing their interest, the interest from OEMs on providing those machines, but need to be together, need to go together with the infrastructure. If there is no infrastructure, there's basically no party at the end of the day. So it's important to me this kind of joint effort between OEMs and local government to make available this infrastructure, showing a real example also.
Marco Bettini, you wanted to add something to this subject?
Yes, just two comments on the presentation of Professor Hui. His main sentence opening his speech was that any innovation in tractors should start from the farmer's needs. I'm not too sure that this sentence is exactly completely right, because out of our experience, sometimes the farmers have a need, but they don't know what kind of a needs they have. And another question is, are we sure that the needs of the farmers are the needs of the country where these farmers are? Because the needs of countries, of developing countries, are very specific. You cannot increase productivity with an average of 1 hectare of farms. There's no way. Yes, you can use service, but that's a long process. But you cannot increase the productivity in a speed way. Let's put it this way. Second, I haven't heard in the power presentation reference to the agronomic techniques. I mean, you cannot increase productivity without a combination between machines and agronomic techniques. It's there where this combination works, where you increase the productivity, where you really contribute to feed the world. But if you keep separate these two worlds, and you don't carefully follow what are the combination of these two worlds, things won't work. This is just my comments.
Thank you, Marco. There is time for one more question. Over there, Andri.
It's okay. Thank you very much. Thank you for these presentations and discussions. I have the question on the first speaker. When you presented it, the different scenarios, do you think that the one of the also realistic scenarios could be increasing of the size of African farms, which make face to the reducing of the labor access, urbanization, and maybe the future it will be the big commercial farms which will have access to more sophisticated and expensive solutions? Thank you.
Okay, thank you for this very interesting question. I think I fully agree. It's not, when you see normally in the future, in coming years, it depends on the regions. We know, for example, in Africa, we are still, say, having, I'm not sure if in the future we will have. Okay. Okay. So I'm not sure if in the coming years the situation will change for many reasons. For the reason, one of, in Asia also, it is a population pressure, this is very important, but we have also other, let's say, other constraints as the inheritance problems, with also the institution, also problems, land problems, also many problems. But it's not the same in Latin America. Maybe in Latin America we have still large farms. This is my opinion. So I'm not sure if in the coming years situation will change. We still have these small-scale farmers. You know, the only solution is maybe the government have to put some regulations and to organize and to manage this situation. This is my answer to your question.
Yeah, I also believe, if I can just close with a comment, that it's very difficult to move from a situation of many small farms into a different one from a physical standpoint. But physical level is not the only one. There is also the service level, the software level, the way you manage land. If you can work on groups of farms, then the group is a big farm. So there are different ways to approach the system and the issue. Of course, there is a transformation, maybe a consolidation of farms, but we need to work in the shorter term also on way of managing this kind of reality. So food for thought in future. I need to close the session here. Thank you so much for your attention. Thank you for all the speakers. The subjects were very interesting, but for the sake of time, we need to really move on. And I hope this will gather and start the conversations in all our team. Thank you so much.
So now we will have the lunch in the same corner. I hope more faster than before, but we are a little bit late, and so we restart at 1:45. Okay, thank you.